So before we get started with example one, I just want to review sine, cosine, and tangent. We talked about that in the last lesson, that sine is equal to opposite over hypotenuse, and it's a ratio there. Cosine is equal to adjacent over hypotenuse. And then the tangent was a ratio of opposite over adjacent. So I just want to kind of review how this works and then talk about inverse sine, cosine, and tangent that we're doing today. So let's say that I have this triangle here, and just for the sake, let's just say that this is a 30, 60, 90 triangle. So let's make this simple, and let's say that B, my short leg, let's say that's 4. So then C, my long leg, is going to be 2 times my short leg, so that's going to equal 8. And then my long leg is going to be the square root of 3 times my short leg. So I'm going to write that in decimal form to 2 significant figures, or out to the hundredths place. I'm sorry I used the term significant figures. That's out of chemistry, and you'll be learning about that later. So we're going to write everything out here to the hundredths place. So realize this is an estimate there. So what we can do is, what the ratio is saying is that if I take, let's say, the tangent ratio first, which is opposite over adjacent, that tangent ratio would be equal to my 4.00 divided by my 6.93. And that ratio, 4 divided by 6.93, is equal to 0.577. We'll only take it out to the hundredths place. So that gives me an actual ratio, but that's actually tied to a degree, that 30 degrees. So think about it this way. If I take and I just go, okay, so I'm going to draw a similar 30, 60, 90. So this is 30 and this is 60, but I'm going to cut everything in half. I'm going to cut everything in half. So 4 divided by 2 is 8, is 2. 8 divided by, so let's put 2.0 here again. So 8 divided by 2 would be 4.00. So I'm reducing everything by half. So 6.93 divided by 2 will give me 3.465. But I'm going to round that up to, oh boy, what is going on today? I'm going to round that to 3.47. So if I look at my tangent ratio again, from my 30-degree angle, that's going to be 2.00 over 3.47. So when I divide that, I say 2 divided by 3.47, I get 0.576. And if you notice, I get the same ratio. Now it's off by 1/100th of a point there, or 1/1000th of a point, because of the rounding error. Okay, so remember, this tangent is when we're looking from what is that? This tangent is when we are looking from the 30-degree angle point of view. I get that tangent. So this would be tangent of 30 degrees. So if I have any right triangle and I have a 30-degree angle, the opposite over adjacent from that 30-degree angle will always be this right here, 0.577. So what that allows us to do is figure out, using the tangent ratios, to go backwards. Instead of like finding the angle, we go backwards, and instead of finding the side, we go backwards and we find the angle. So let's take a look at the tangent ratio from my 60-degree angle. So if I say tangent 60-degree angle. That's going to be my opposite now is 6.93, and my adjacent is 4.00. So when I do that, 6.93 divided by 4, I get the ratio of 1.7325. Now I'm going to write that all the way out. And this is what I want you to do. On your calculator, we're going to see that that's 60 degrees. So if I just say my tangent is my tangent of some degree is equal to 1.7325. So if I know my ratio, but not the degree, in my calculator, I can just take, you will see something that will say probably like tan -1, or it might actually say arctan. It's just the inverse of it. It's saying, let's take the ratio and find out what angle it is. So if on my calculator, I have to hit my second button, then my tan, because that's where the inverse is at. And when I do that, I get this answer, 60.006. And it's telling me it's a 60-degree angle. Now, remember, since this is the square root of 3 here, and I'm estimating it, that's pulling in a little bit of error. But let's go ahead and take a look at number 1. It says, use the sides of the triangle and calculate to find the value of angle A. So if I look at angle A here, I have the opposite side and the adjacent side. So that's my tangent A is equal to opposite over adjacent. So that is equal to 20 over 25. So my tangent of A is equal to, and I can say 20 divided by 25. That gives me 0.8. So that is the ratio of those sides. Now I need to find out what angle that tangent ratio is associated with. So I'm going to say, my calculator, I have to put in my value first, my 0.8, and then second tan for arctan. And that gives me 38.65. And they want this to the 10th of a degree, so it's 38.7 degrees. 38.7 degrees is the measure of angle A. So we'll just say, well, anyways, measure of angle A is equal to 38.7 degrees.